video, we are going to take a look at parallelograms, and parallelograms are very similar to squares and rectangles. We can decompose them to create another shape, which is pretty cool. So what I'm going to do is just kind of show you. We'll start with the green one here, the larger one, and then we'll look at each one of these. So I have this parallelogram, and I notice that the sides are slanted. And when I'm trying to find the area of a parallelogram, I want to be careful because I don't want to measure the slant side. I want to make sure that I have a base and a height. Remember, we're looking, and I'm going to pull graph paper again. We're looking, when we're doing area, we're looking for that right angle. See that? We're looking for that right angle. And again, remember when we did rectangles, we had a base and we had a height, and we had 1, 2, 3 going across the bottom, right? There's 3, but then going up the side, I have 4. I notice this one overlaps, right? That's the right angle. So we don't have any right angles with a parallelogram, but we can make them. So what I'm going to do is I'm going to just use a straight edge. I'm using the ruler not to measure, just to use as a straight edge. And I'm noticing I can make a right triangle here. So like if I just line my ruler up as straight as I can, okay, I'm going to make a right angle. A piece of paper would work as well. So like if you had just a post-it note, you can find a post-it note, and you want to make sure your angle's a right angle, just line it up. See how I just did that? Okay. All right, I'm going to draw a line just to make sure I make my cut straight. Okay. And I'm just going to trim off this corner of the parallelogram. Trying to make it as straight as possible. Okay, so I still have a parallelogram, right? But what I've done is I've partitioned, decomposed, to make a right triangle. So I know I have my right, there's my right triangle. I now have a height and a base, but notice the base is smaller at the bottom than it is at the top. This is actually a trapezoid. See, if I rotate around, you can see the trapezoid? By cutting off the corner or the right triangle section of the parallelogram, I've created a trapezoid. Now watch how cool this is. I have a height now, which is what I want. And if I take this shape and I just do this little slide over, all I'm doing is moving it from this side to this side. I've now created a rectangle that has a base and a height because I just cut this off. So I know this is a right angle. See how I'm going to show you, see that? So I know that these two are right angles. I've cut this off. I'm just taking this triangle and I'm relocating it to the other side. It's still the same shape. It's still the same shape. It's still the same area. I didn't change. I didn't cut anything off to make it smaller. I just took the piece, separated it, and relocated it to the other side. Pretty cool, right? And now I have what looks like a square. It's a little bit longer, it looks like, but there's a rectangle. So then once I know that, I have my base and my height. So I can just do multiply base times height. That's what I have, my base and my height. It's always been there. But because a parallelogram is slanted and we don't have that nice right angle, we're creating the right angle by just cutting off the left side or right side, sliding it over here. Okay? All right, let's take a look at another one. Let's take the pink one. This time I'm going to go over from this side. So I have, and again, you can reverse. See how I can kind of reverse my parallelogram? Still the same, just flipping it. I'm going to cut this corner off. Again, I want to make a right angle. So again, if you have a straight edge post-it note, it's always work really good, or a ruler. I want that corner. I want that right angle there. So I'm just going to draw a line because I want to make sure my cut is good. That looks pretty good. It's easier with graph paper. I'll show you next. I'm just going to cut straight down. Okay, now I have the right angle. Now it's upside down, but that's okay. If this is a right angle and this is a right angle and I cut it straight, that means this is also a right angle. Okay, so I've just cut off my section of my parallelogram. Still see, it's still here. I'm just creating the height that nice perpendicular straight right angle. And then I can take my triangle and just slide it over to the other side. And now I've made a rectangle. So I went from a parallelogram, which would have been harder to measure, right? It's harder to measure these slanted sides. We need that perpendicular line, those right angles. We want to make sure that our base and our height make that perfect L. That's called perpendicular. By cutting off the corner, I've created that perpendicular line, but I don't want to get rid of this. I'm just relocating it to the other side. It's like a puzzle piece. Now I just have a rectangle, good old rectangle, length times width. Done. All right, let's try another one. Let's do this one. Okay, so for this one, I'm going to look at it from this perspective. What if it's standing up like this, right? Standing up. Ugh. How would we cut this one off? Well, again, I want to make sure I use a nice straight edge. I see it right here. See that? If I just take my Post-it notes, maybe a ruler, just kind of straighten it out a little. Look at that. There's my right angle. So I can cut that off. See the right triangle right there? Okay, so I'm going to draw a line. And I'm going to trim off this side of the parallelogram, straight as I can make it. Again, I'm using scissors and I'm cutting with thin paper, so it might not be perfect. Okay, so here we go. There's the parallelogram. I'm taking the triangle. I'm cutting this off so that I can make a nice right angle. I want a height and a base. I don't want a slant. And by doing that and making this right triangle here, I can now slide this over, piece it together, and I've got my right angles. See, there I have a rectangle. Now I can just do base times height. So if I know the base and the height of this, then I can just slide it on over, piece it together, and connect it. Now, one thing I want to caution you about is the slant. We don't want the slant. We do not want this measurement. That's the hypotenuse of this triangle, and we don't need that. We want the base and the height. So remember, the base and the height are always going to form that right angle, that corner. So we don't want the slant measurement. That would be the hypotenuse. We want the height and the base, that right angle. So when we slide this over, we're looking at the base and the height. Okay? All right, last one, and then we'll do some on graph paper. All right, let's do it. Let's do one like this. What if it's standing up like that? Well, we can make our triangle at the bottom. See that? Like, see the triangle? It's like right there. Again, I'm going to use a corner. Paper, like a piece of paper is always good because then you can like, see how I'm lining it up? Right? I'm lining it up right with the paper. And then I can see the straight. I can just draw a line. See that? And I can just slice it, cut it off the bottom. Just cutting it off. All right. Okay, so there's the parallelogram. It's still a parallelogram. I'm just taking off that corner. The reason why I'm doing that is I want that right angle. See that? I want the right triangle. Get that piece of paper out of there. And I'm just going to relocate it. Slide it up just like a puzzle piece, and now I've made a rectangle. Okay? I went from parallelogram to rectangle. The key to this is making that right triangle. That's the key. It's very important that when you're looking at your parallelograms, you're going to find the point and you're going to draw a straight line down. Again, using like a corner, something with corner, like Post-it note, paper, even if you just have like a piece of paper handy, like a piece of paper will work. You can just kind of line it up and then cut and make that nice right triangle. That's the key to this. Okay, slide it up, rectangle. All right, let's take a look at some on graph paper. All right, so pull some graph paper down, and I'm just going to make a parallelogram. Okay, so I'm going to go across here at the top. And Then I'm making the diagonals. All right, so here's my parallelogram. Okay, make it a little bit darker so we can see. Now, when you're working with paper, it's a little bit harder because you can't cut. I mean, you could cut, but you know, if it's a worksheet or on a test, you can't cut the paper like we did in our practice. Okay, so like here's a parallelogram. Let me see if I can like reconstruct this real quick. Okay, here we go. See, I have the exact same, pretty much same, just enlarged parallelogram here on my paper. As I do, I cut this and then I slid it over here, but I can't really do that on paper, but I can. It might be actually easier for some of you than cutting. So here's my right angle. You see it? It's right there. And I'm going to highlight it in yellow. Right? So imagine cutting this off and sliding it to the other side. So I'm going to just do this little number. And now it's here. Okay? Now the tricky part with this is that we've actually removed it. We've taken this and we've just relocated it on this side. So really we just have this rectangle. So now that we have this, we can maybe use a piece of paper or something just to cover it up because you can't cut it. But you can see now that it's a rectangle. So now I can just say, okay, well I've got 1, 2, 3, 4, 5, 6 is my base, and 1, 2, 3 is my height. And 6 times 3 is 18 square units. So my original parallelogram, which was right here, even though I can't count the diagonals, I don't know what that side is. I mean, I can measure it, but that's not going to give me the area. I need that perpendicular line. So I took this triangle and I relocated it to the other side and I formed my rectangle. Then I can just count the boxes. 3 times 6. Okay? 3 times 6 is 18. All right, let's look at it one more way. Let's see if we can make one more. I'm going to make a vertical one this time. All right, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to connect the dots here. All right, so I made a vertical parallelogram standing up. Okay. And again, I can see, some of you may start to get really good at this. You can see the triangle. It's right there. See it? Okay, so if I were to take this triangle and just relocate it up here. So I'm just taking this triangle and sliding it around, and it's going to fill in the space right here. Look at that. See that? So I'm taking it away from the bottom and I'm moving it to the top. And once I do that, again, you can cover it up with your hand. You can't cut it. It's on graph paper. So you can just sort of imagine I'm subtracting it and I'm sliding it up. So now I have 1, 2, 3, 4 at the top. 1, 2, 3, 4, 5, 6, 7, 8. 8 times 4 is 32. 32 square units. Okay? All right, so when we're working with parallelograms, we're actually doing a little trick where we cut off the corner of that parallelogram. We make that right triangle and we just slide it around like a puzzle to construct a rectangle. Now, as you start to practice with this, you will learn that the area of a parallelogram is just like the area of a rectangle. So if you have a rectangle, I'm just going to sketch a rectangle. We know it's length times width, or like I've been saying, base times height, which is what I like. So I think of it as like the base times the height. That's kind of how I like to look at area because I know I need to make that right angle. There's my height. Here's my base. Okay. Now, parallelograms have the same formula because a parallelogram, again, is essentially a rectangle. If I think of it as, let me put this back, there's my parallelogram, base times height. If I take this corner off, this triangle off, triangle off, make that right angle, cut it, and move it over, I've just constructed a rectangle. And the formula for a rectangle is height, length times width, or base times height. We can use the same formula. So eventually, you won't even need to do this where you're physically moving it from one side to the next. All you'll need to remember is you need the height and the base. So even if, let me go show you one. Let's say, here, where's my ruler? Let's say we have, make a little one here. Okay. Now, instead of cutting, I want to show you. We have a base of 1, 2, 3, 4, 5. There's a base of 5. Remember, even though it's cutting the box in half, we know that the other half of it is over here, right? We're going to remove it from this side to this side. So we can count this whole base. The whole base goes from here to here. That's 1, 2, 3, 4, 5. That's 5 units for the base. Now, what is the height? Now, this is where it gets a little tricky. The height is how far apart the top and the bottom lines are. We don't want the diagonals. We want that perpendicular. So the height can be found a variety of places. Here is one height right here. Here's the base. Here's the height. 1, 2, 3. So there's 3 units. 1, 2, 3. We can also see the height here. We could look at it going up. 1, 2, 3. We could also go inside the shape. Here's a height. 1, 2, 3. Here's another height. 1, 2, 3. Here's a height right in the middle. 1, 2, 3. The distance between the top and the bottom is the height. So we can see it's 3 no matter where we check it. So we know the base is 5 and the height is 3. And once we know that, we can just do 5 times 3, which is 15. It's 15 square units. We didn't have to move it over. We didn't have to move the triangle over because we know if we know the base and we know the height, it's exactly the same as a rectangle, base times height or length times width, okay? All right, so we're going to do some more practice with parallelograms. They're super fun. Just remember that a rectangle and a parallelogram are essentially the same. The formula is the same, base times height. The only difference between a rectangle and a parallelogram is that the parallelogram is slanted, and in order to find the height, we don't want to use the slanted sides. That's a no-no. We want that straight perpendicular. And the height is going to be how tall the top and the bottom, how far apart the top and the bottom are. And we use the formula base times height, just like a rectangle, because if we cut off this triangle and move it to the other side, it's the same as a rectangle. Okay, so a parallelogram and a rectangle are very similar. Same with a square and a rhombus. You can do this exact same thing with a square and a rhombus.